For as long as humanity has walked beneath the stars, we have looked upward with wonder. The night sky has always been more than just darkness sprinkled with points of light. It has been a mirror of our questions, our fears, and our dreams. Generation after generation, one question has lingered longer than all the rest. Are we the only ones? The ancients filled that silence with stories. They told of gods riding chariots of fire, of celestial palaces hidden beyond the stars, of spirits watching from above. These myths were humanity's first attempt to explain the vast, unanswerable silence. Later, philosophers wrestled with the same mystery. Was Earth a unique sanctuary, a single oasis of life in an infinite desert? Or were there countless other worlds, unseen but alive, orbiting distant suns? As centuries passed, science took the place of myth. Numbers replaced legends. Telescopes mapped the heavens. Astronomers counted stars, traced their motions, and realized that our galaxy alone holds hundreds of billions of them. When planets began to reveal themselves orbiting those stars, the question grew sharper. If the universe is so vast, how could life exist only here? And yet, for all the calculations, for all the searching, the cosmos remained silent. Radio telescopes scanned the sky, listening for the faintest whisper of intelligence. Probes journeyed beyond the solar system, carrying messages from Earth. Equations multiplied on chalkboards, estimating the odds of life. But no signal ever came. The silence became like a wall, an unseen curtain drawn across the universe. A curtain we could look through, but never pass. For thousands of years, humanity asked. And for thousands of years, the stars gave no reply. Until now. The world beyond the curtain. Just 120 light-years away, orbiting a small red dwarf in the constellation Leo, lies a planet unlike any we have ever studied. A world with the power to shift astronomy, biology, and even philosophy itself. Its name is K2-18B. At first glance, it is not Earth's twin. It is larger, more than twice our planet's size and nearly 9 times its mass. Its gravity is stronger, its atmosphere denser, its oceans deeper and broader than anything we know. Yet despite its alien scale, it rests in the most precious region of all, the habitable zone. That delicate band where liquid water can endure, where temperatures are stable, and where life has its greatest chance to take hold. The first signs of life beyond Earth. When the James Webb Space Telescope turned its powerful instruments toward K2-18B, scientists expected an ordinary reading. Instead, they found something extraordinary. High in its thick hydrogen atmosphere floated the unmistakable fingerprints of biology's raw ingredients: water vapor, methane, carbon dioxide. Gases essential to the chemistry of life. But then, hidden in the data, came something that stopped researchers cold. A faint but undeniable signal: dimethyl sulfide, or DMS. On Earth, this molecule comes from only one source: life. Tiny plankton in our oceans release it as they drift beneath the waves. On no barren rock, no sterile desert, and no dead world does it appear. It is not imagination. It is not myth. It is measurable, repeatable, scientific fact. And for the first time in history, humanity may be staring at true evidence of alien life. The nature of a Hycean world K2-18b is part of a rare class of planets called Hycean worlds. These are planets wrapped in hydrogen-rich skies, shielding vast oceans below. Imagine a world entirely covered in water, no continents, no mountains, only endless seas stretching farther than any horizon. Under those oceans could exist climates stable enough to allow chemistry to unfold and evolve. It is a kind of environment Earth once knew. Billions of years ago, our own planet may have looked the same, a water world with a raw atmosphere, where the first fragile sparks of biology began their journey. Now, on K2-18B, history may be repeating itself. Life in an alien ocean. What form could life take there? Some scientists believe it might be microbial, vast clouds of microscopic organisms drifting through alien waters. Others allow themselves to imagine something more, creatures adapted to crushing pressures, moving gracefully through endless oceans, feeding, reproducing, and evolving along paths completely unlike anything Earth has ever seen. Perhaps K2-18B is not simply inhabited, but alive with complexity. Perhaps its seas are not silent but teeming. And perhaps, just perhaps, it is evolving toward intelligence. Should humanity reach out? With discovery comes a new and uneasy dilemma. If life is truly present on K2-18B, what should we do? Do we try to reach across the stars, sending greetings, signals, and messages in the hope that something, or someone, is listening? Or should we remain silent, careful not to disturb what could be a fragile ecosystem, one that might only now be awakening from the deep silence of cosmic history? Even the mechanics of communication are staggering. If we sent a message today, it would travel across the void for 120 years before reaching K2-18B. And if anything there were to answer, that reply would take another 120 years to return. A single exchange, a single hello and reply, would last almost a quarter of a millennium. So the real question is not can we speak? But should we speak? Would we be explorers or intruders? The world reacts. When the James Webb Space Telescope's findings were made public, the world reacted with a rare and powerful unity. For once, the headlines were not about conflict or division, but about wonder. Newspapers, television broadcasts, and news feeds around the globe carried the same story. We may have found life beyond Earth. Social media ignited. Hashtags like #K2-18B, #AlienOcean, and #WeAreNotAlone trended worldwide. For the first time in generations, humanity's gaze shifted upward together, away from the daily struggles of politics and survival, and toward a shared cosmic question. Are we no longer alone? The effects rippled quickly. Universities saw surges of new students inspired to study astronomy, astrobiology, and physics. Governments and space agencies began sketching the outlines of new missions, probes, telescopes, and even long-term concepts of interstellar exploration. For the first time in decades, the idea of reaching beyond our solar system no longer felt like science fiction, but a challenge waiting to be met. And in that moment, humanity felt, if only briefly, united, not just with one another, but with the universe itself. The deeper mystery yet beneath the joy and the wonder lies a deeper question, one that is far older, and far more unsettling. If life exists on K2-18B, why has the universe been so silent? This is the riddle known as the Fermi paradox. With billions of stars in our galaxy, with countless planets in habitable zones, the odds suggest that life should not only exist, it should be everywhere. Civilizations should be visible. Their signals, their probes, their footprints across the stars should be obvious. And yet, we see nothing. Perhaps most life never moves beyond the microbial stage. Perhaps intelligence is far rarer than we imagine. Or maybe civilizations destroy themselves before they ever reach the stars, consumed by their own struggles. There is another possibility, that life is common, even intelligent, but it chooses silence. Perhaps communication across the galaxy is dangerous. Perhaps silence is the cosmic survival strategy. And if that is true, then silence itself is not an absence, it is a warning. A new chapter for humanity. Whatever the answer, K2-18B changes how we must see ourselves. It forces us to rethink the very foundations of biology and our place in the universe. On Earth, life breathes oxygen, thrives on nitrogen, and feeds under a bright yellow sun. But on K2-18B, life may breathe hydrogen, may harvest faint energy beneath the dim glow of a red dwarf star, and may adapt along paths we cannot yet imagine. It reminds us that Earth is not the blueprint of life, only one version of it. If organisms exist there, then our planet is not the exception. We are not the center of biology, only one chapter in a much greater story the universe has been writing for billions of years. The James Webb Space Telescope did not deliver this revelation with a roar. It whispered it, quiet, precise, undeniable. A signal faint in the data, but profound in its meaning. A reminder that the cosmos is not empty. It is not silent. It is alive. It is becoming. The choice before us now, humanity stands at the threshold of something extraordinary. Not the question of whether we are alone, but the far greater challenge of how we will live in a universe where we are not. Do we reach out, announcing ourselves to the stars, ready for the consequences, whatever they may be? Or do we listen, patiently, learning first before we speak? For centuries we stared at the sky with curiosity. After K2-18B, we must look with responsibility. Because the curtain of silence may finally be lifting. And what lies beyond will change not only science, but the destiny of humanity itself.